To translate quadratic relations, we're going to use the standard form of the ellipse and standard form of the hyperbola. So the standard form look the same for both. Just note the differences here. The differences are the hyperbola has a minus and a plus minus here, okay? Whereas the standard form is plus between the quadratic terms of x squared and y squared, and it's always equal to a positive. So the translations are going to be done just like with parabolas, where we have the h value is a horizontal shift, and the k value represents the vertical shift. And the horizontal and vertical shift will locate the center. So the center is going to be at hk, and the distance between the vertices then become twice double of a. So a gives us the distance to the right and left, okay, along the x-axis. If the vertices are along y, then we have the vertices have a distance of 2b. So we go b up from the vertex, or from the center, and b down from the center. Okay, so we have these expressions that we can use for the vertices of the trans x or y vertices. With the standard form, the vertex of the ellipse, the vertices are going to be the same. Okay, so we can find the center at hk, and we go 2 up from, 2 to the right and 2 to the left from k to get the vertex, the left and right vertex of the ellipse. And we're going to go plus b and minus b from k to get the vertical vertices of the ellipse, or the top and bottom of the ellipse. So these represent the standard form, or the graphing form, and we're going to use those to locate first the center, and then we're going to use the a and b values to determine where the vertices are. So an example here is when we have 25y minus 4 all squared plus 100x plus 2 squared equals 625. So first of all, notice that it is plus and that this constant term is positive. This is an ellipse. We want to make this equal to 1, so we're going to first of all divide by 625. So we get 25y minus 4 squared over 625, which we're going to simplify the common factors. We have 100 x plus 2 squared all over 625, okay, and that's going to be equal to 1. So simplifying these common factors, we're going to simplify this to y minus 4 squared and take out the common factor of 25, so we get 25 over 625 reduces to 1 over 25. 100 over 625 simplifies to 4. So we take out the common factor of 25, and we end up with 4 over 25. Okay, so the a value we're going to establish as a is equal to 5. The b value comes from the reciprocal of 4 over 25, which is 25 over 4. So we're going to square root that. So we get 5 over 2 is the length along b. The center we get from our h and k values. So that is our k, that is our h. So make sure that you notice that the x and y is a switch. So the center is located at -2 along the x, +4 along the y. Okay, so we've established the graphing form. We found the center, a and b. So we're going to graph this. We're going to locate the center first. So 2, +4 represents the center. And using the a value, I'm going to go 5 to the right to locate the vertex, 5 to the left to locate the vertex. And then from the center, we're going to go up 2.5 and down 2.5 to locate the vertices, the vertical max and mins and we have the left and right points here. So from that, we can just draw in our ellipse. Let me try that again. Okay, so that's our ellipse. Our center is located at -2, +4. Our vertex, we have 3 and 4 on the left, on the right. We're going to have a coordinate of -7, 4. At the top, we have -2, 6.5. And at the bottom, we have -2 and 1.5. So in this example 2, again, first of all, notice that we have a minus between the quadratic terms. It's equal to minus. It's an x squared minus y squared quadratic equal negative. So this is a trans y. So we're just going to make note of that. This is a hyperbola, and it is trans y. So we're going to divide by 100, so we get 25 x plus 4 squared all over 100 minus 4 y minus 1 all squared over 100 equals -1. Simplify the common factor. We're going to divide that both by 25. We get x plus 4 over squared over 4 minus, and this, we're going to simplify this into y minus 1 squared over 25 equals -1. So we're going to work out the a value. The a value comes from four, so we have a equals 2. Our b value, we have end up with b equals 5. Okay, the center comes from our shifts here and here. So the center is at -4, +1. Okay, so we have our graphing form. We got our A and B. We have our center. We can graph this. We're going to graph the vertices first. So -4, +1 represents the center. Using the x-axis radius, we go, or the A value, go 2 to the left, 2 to the right. Using the y-axis radius of the B value 5, we're going to go 5 up and 5 down. Okay, so this is a hyperbola, so this is where it differs from the ellipse. We're just going to locate the corners of that rectangle, and I'm going to sketch in that rectangle just to give myself a visual to let me kind of see what the slopes are here through there. I'm going to sketch in my slopes. Okay, there's one slope. Okay, so this represents my asymptotes. We know that this is trans y, so we're going to use the y-axis vertices to draw the graph. So sketching in the graph, I use a vertex. I follow the asymptotes. It's the same here. Start with the vertex and follow the asymptotes. Okay, so the last thing we're going to do is we're actually going to work out the equations of these asymptotes. So the asymptote equations we're going to use a point slope form. And the reason we're going to use a point slope is because we already have the point that they share, which is the vertex at, sorry, the center at -4, +1. And we know the slopes. The slopes are going to be plus minus b, which is 5, over a, which is 2. So then the equation of my asymptotes work out to be y equals 5 over 2, x plus 4 plus 1. And we can do plus minus, but I'll just do them in separate equations. -5 over 2. That is a negative diagonal slope. It passes through the center of -4, +1. So putting into the point slope form, we get those two equations of the asymptotes.